Business Mathematics 1, Linear Algebra. Unit 2, how to calculate a parameter so that the matrix is diagonalizable. Exercise number 15. Calculate A such that the matrix A is diagonalizable. To solve it, we must know how to calculate P of lambda and its roots, which can be found in definition number 7 and property 9 in the tutorial given by the teacher. How to calculate eigensubspaces and their dimension, which can be found in definition number 4. And to know when a matrix is diagonalizable, which can be found in the properties number 17 and number 20. Now, let's solve it. P of lambda equals A minus lambda 0, 0, 3, 2 minus lambda 0, 1, 4 and A minus lambda. So the determinant of this matrix is A minus lambda squared times 2 minus lambda. Lambda number 1 equals A, and the multiplicity of this lambda is 2. Then by continuing the calculations we find that lambda 2 equals 2 with multiplicity 1. As the multiplicity of 1, we don't have to check the dimension because the dimension of any eigenvalue with multiplicity 1 is the same as its dimension. We have to check the multiplicity, not the other eigenvalue, which has the multiplicity 2. By doing these calculations and then solving the equation system, if we want A to be diagonalizable, we want the dimension of H to be equal to the multiplicity. We want the dimension to be 2, so we want one equation in H. For the eigenvalues to work, we need that A times U equals A times U. Obviously the at A being lowercase. So we do these calculations. Here the video is showing us that for A to be diagonalizable, the dimension of H has to be the same as the multiplicity of lambda, which is 2. For that to happen, we need one equation in H. In this equation system, we have 2 trivial equations, meaning that they don't give us any information. One of them is AX equals AX. Well, in this trivial equation, ax equals ax. By resolving this equation, ax minus ax is always 0, which means that 0 equals 0, which doesn't give us any information. By replacing values in the third equation, we have that x plus 4y plus az minus az equals 0. By solving this equation, x plus 4y equals 0, which tells us that x equals minus 4y. To get the value of a, we must substitute the x equals minus 4y in the second equation. By doing this, we have that 3 times minus 4y plus 2y minus ay equals 0. By continuing to resolve this equation system, we have that minus 12y plus 2y minus ay equals 0. By continuing to resolve this equation, we have that minus 10y minus ay equals 0. By using y as a common factor in this equation, we have that minus 10 minus a all times by y equals 0. Here we have another trivial equation which says that 0 equals 0. The second answer would be that minus 10 minus a equals 0. So here a equals minus 10. In this equation, we need that a equals minus 10 in order for a to be diagonalizable. To summarize, when talking about diagonalization, when the multiplicity of lambda equals 1, we are sure that dimension of h of lambda equals the multiplicity of lambda, lambda obviously being the eigenvalue. We only need to check it when the multiplicity of lambda is greater than 1. To calculate h of lambda, we must solve f of u equals lambda times u, or a times u equals lambda times u. Obviously, we need to take into account that the dimension of h equals the number of variables minus the number of non-trivial equations, meaning that it is minus the number of equations that give us some information.